Hi and welcome back. In the previous video, we talked about data and functions. We now know that data in programming can be represented either by literals or by variables. We also know that functions are essentially named code segments that process data. In this video, we're going to talk about another element of programming that represents data processing. I'm talking about operators. Unlike functions, operators perform just one operation. We've already used assignment operator represented by the equal sign and responsible for assigning data to variables. But the assignment operator is not the only one of its kind. For example, the plus symbol is called the addition operator, and as you can probably guess, it adds up to numbers. So without further ado, let's see how we can use the addition operator in code. First of all, let's copy the code from the previous lesson, create a new file named lesson3.c, paste the code, and delete this part to get a clean slate. Alright, again, what we're going to do now is we're going to look at how the addition operator works. For this, we're going to print the result of addition of, say, 5 and 10. Now, the sum of two integers is an integer, and to have it printed to the printf function as a first parameter, we pass what? Right, %d. And we get 15 printed in the console. Now let's do the same, but instead of using numeric literals, let's use variables, like this. And we get the same 15 in the console. Alright, next, let's make the output a little more informative. Specifically, let's output in the following format, where a and b are the values of the variables a and b respectively, and c is the sum of the values. Now we can't just type something like this, since it will literally print a plus b equals c. What we need to do is we need to replace a, b, and c with formatted string parameters, like this. And it works the way it should. And it will still work even if we change the variables a and b. Now, please note that we do want to leave the plus and the equal signs as well as the spaces between them as regular characters. But if we wanted, we could replace those with string parameters, like this. Here, to represent an individual character in C, we use the data type char. Please note that char is not the same as char asterisk. The char asterisk represents a string that can contain multiple characters. For example, this string consists of 3 characters, a space, an equal sign, and another space. Also, character literals go inside single quotes, while string literals go inside double quotes. Next, to interpret data as a single character inside the formatted string, we use %c, while for strings, we use %s. And since the variable c is just a single character, we do need to leave spaces here. And since the string d already contains spaces around the equal sign, we do not need spaces inside the formatted string. Now, this is just another example that shows how formatted strings work. There is no practical reason to use these extra variables, but it should help you get more familiar with formatted strings in general. Now, in addition to addition, there are also subtraction, multiplication, and division operators. So why don't you try to repeat this printf for these 3 operators. In order to practice using formatted strings, let's add more variables to represent arithmetic operations, like this. Okay, so this is what you should have. Pay attention to the spaces. Now, if we run the code, we'll see that the outputs got jammed together even though we are using separate printf function calls. And this is something to be aware of. This is just how it works. To have each output in a separate line, we need to add a new line character at the end of each formatted string. Yes, there is a new line character, and yes, it's a character. To add a new line character, we go \n. You can find the / key below the delete key on your keyboard. And now all 4 operations are printed in separate lines. Now, there's another arithmetic operator in programming called modulo, and it's represented by the % symbol. The modulo operator gives you the remainder of integer division. For example, if we divide 6 by 4 and discard the fractional part, we will get 1, and the remainder of division will be 2, meaning 6 modulo 4 is 2. Alright, let's add it as a 5th printf for the modulo operation. The modulo operator is represented by the percent symbol. However, since formatted strings use the percent symbol to represent string parameters, to actually add the percent symbol to a formatted string, we need to type two percent symbols. And if we run the code, we will see the result of the modulo operation. Now you might be wondering why the modulo operator exists in programming. What's the use of getting the remainder of division? Well, you can use the remainder of division, for example, to check whether a number is odd or even. If the remainder of division by 2 is 0, the number is even. And if the remainder is 1, the number is odd. Also, you can use the remainder to test whether a certain number is prime or not. But we're not going to do any of that, not now. What we're going to do now is we're going to look at the result of division, which for some reason is 0. And this happens because in programming there are two types of division, integer division and floating point division. The result of the integer division is an integer number, meaning a number without a fractional part. Here are some examples of integer numbers. Now, the result of the floating point division is a floating point number, meaning a number that has a fractional part. In C, int is a data type that represents integer numbers, while float is a data type that represents floating point numbers. Now, why do we need to separate integer and floating point numbers? Remember, computers can only process binary data, and binary data is represented by a sequence of ones and zeros. So both integer and floating point numbers have corresponding binary representations, but those binary representations are not the same. For example, this is a binary sequence for the integer number 5, while this is the binary sequence for the floating point number 5.0. And this binary sequence, if interpreted as an integer number, represents this number, while if interpreted as a floating point number, it would correspond to this number. Alright, so we have two types of numbers, and as a result, we have two types of division. What we see here in the console is the result of the integer division. So how do we get the result of the floating point division? In C, you use the same / operator for both the integer and the floating point division. And the type of division is determined by the data types of the numbers, meaning if both numbers are integers, then the integer division is applied. And if at least one of the numbers is a floating point number, then the floating point division is applied. So what we can do is we can declare a float variable and assign it the variable a or b, doesn't really matter. And yes, to variables, you can assign other variables, not just literals. Please note that here, we're assigning an int variable to a float variable. Int and float are different data types, and normally this wouldn't work. I mean, you can't assign a string to a numeric variable. But it does work here because both int and float represent numbers. However, it won't work if you try to do it the other way around, meaning if you try to assign float to int. But we're not going to talk about that just yet. Now, we use this variable h instead of the variable a here. And since the result of the floating point division is a floating point number instead of %d here, we need %f. And now we get the result of the floating point division. Alright, next. Formatted strings can not only be used to incorporate non-string data into a string, they can also be used to format that data. For example, for a floating point number, we can specify the number of decimal places by adding additional stuff in between the % symbol and the letter f. Specifically, we need to add a point, followed by the number of decimals we want to see after the point. Let's go for 2. And if we run the code now, we will see that the result of division got rounded to 2 decimal places. Alright, next. Currently, we print the result of arithmetic operations performed on 2 values that we predefine here, using numeric literals. To make this code a little more useful, instead of hard-coding the values for the variables a and b, we're going to assign them the values provided by the user. Now, this printf is a function whose job is to display or output data to the console. To have the computer take input that the user provides, we need to use another function. The name of the function is scanf, and it works similar to printf. For the first parameter, we need to specify the format of the input using a formatted string. And we also need to specify the variable that will be used to store user input. But if we run the code, we'll get a warning that the scanf function requires an int asterisk, not an int. And if we don't fix this problem, the code will not work properly. To fix it, in front of the name of the variable, we need to add an ampersand symbol, like this. We'll talk about this in more detail next time, and for now, let's try running the code. If we do that though, we'll get a message saying that the code is already running. To stop it, we press the stop button and hit the run button again. To see no warning, but we can't really provide any input. While this active stop button suggests that the code is running, and it's running because it's expecting user input. And this is something to do with VS Code, so let's stop the code, open Settings. Here, we'll look up code runner.run and check this box. And now if we go back to our code and run it, it will run in a different tab, specifically the Terminal tab. And if we click inside the Terminal panel, we will be able to type in some input. And if we press Enter on the keyboard, we will see the result of the arithmetic operations for the number we just typed in. Alright, let's now do the same for the variable b. And we can now type in two numbers and see the result. Next, to be a little more informative, let's display a message for the user to make it clear what the user is expected to do. And it seems to be working, except the first number is stuck to the initial message. How do we fix this? How do we make sure that the input is displayed in the next line? Any ideas? We need to add a new line character at the end of the prompt, like this. And now it makes more sense. Now we still have this ampersand operator that we haven't talked about yet, and we will save it for the next lesson since we have already covered a lot in this one. As usual, to test a grasp on the material covered in this video, you can take a quiz that you can find on our Patreon page. The link is in the description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye.